about the experiments conducted by 3 different people, we have to recall the experiment conducted by Griffith. Griffith conducted experiment what is called Bacterial Transformation experiment, in which he did experiment in the case of a bacterium, Streptococcus pneumoniae. That's one which causes pneumonia. He started experiment to find out, that is, how to cure pneumonia. But amazingly, he had observed a transformation from one bacterium to another, a physical change from one bacterium to another. So, in 1928, he conducted experiment. Now, the different stages. Now, if you're taking the bacterium, this pneumococcus or Streptococcus pneumoniae, we have 2 different types of bacteria. One just with a smooth surface, one with a smooth surface, having a capsule, and this is called as the S strain. This is called S strain. Having smooth surface. The smooth surface is because of the polysaccharide. So this is what is called a mucus coat. Mucus coat. So a bacterium having, that is this bacterium having the mucus coat made up of polysaccharide is having a smooth surface, hence called S strain. Another bacterium that is without this polysaccharide coat or the mucus coat is called R strain. This is called R strain. That meaning rough surface. A cell having rough surface, a cell having smooth surface according to their name, that is S strain and then R strain. Now the S strain is a virulent form. A virulent form means the one which causes death. And this is R strain is non-virulent form and without what is called the coat. Later it was found that the death of the individual was caused because of what is called the outer coat, the mucus polysaccharide acting as an antigen. Now what was the experiment conducted by him? He did the experiment in 4 different stages. He took live mouse cells and injected into the body of mouse. Now as it is not having the coat, the animal lives. That is, the mouse lives. So when he did the experiment, this is the first stage. Live mouse cells injected the body of mouse. They lived because actually no polysaccharide coat to cause the death. In the second stage, it took live S cells having the outer coat, the smooth coat, smooth surface, and injected it into the body of mouse. Now the mouse died. This is because of the presence of an outer coat, what is called the polysaccharide coat. The third case, he killed, that is what is called the S cells by means of heat. So heat killed S cells. When it is heated, what will happen? Now the outer capsule, the cell wall, all disappear. We have only the DNA. A naked DNA is alone present. Naked DNA. So this is called cell-free DNA or naked DNA. Here he injected what is called the cell-free DNA. That's called the heat kill. This is the DNA alone injected without a protein coat, without a capsule. So the mouse lived because absence of this mucus coat normally didn't cause the death of the organism. In the last case, it took R cells. It took R cells plus what we have, the heat killed S cells. So the heat killed S cells means only the DNA without a protein coat. So before injecting, now this R cell is incubated or cultured with what we have, the cell-free DNA. Now we are taking that one as a heat killed S cell without a cell membrane, a cell wall capsule. So what will happen? This DNA had been taken by what is all these R cells. So it is called actually transduction process. Now the DNA has been taken inside and attached to the DNA of the smooth cell. Now what is happening? Now the R cells have the ability of developing the smooth surface. So when it was injected into the body of mouse, now the R cells, which is in the form of what we have S cells, cast the depth of the mouse. So this is because of what is called actually the outer core, and that one responsible for the death of the organism. But here, what was the transforming principle? What was the substance responsible for transforming this R strain into S strain? He didn't know. He simply conducted the experiment. The experiment was called transformation experiment. But he didn't know the cause of transformation. Also, he didn't know about the biochemical nature of the genetic material. Something is transferred from what is called S cell to the R cell, converting the R cell into S cell, so that it causes the death of the organism. So this is what we call the Griffith experiment that was conducted in the case of Streptococcus pneumonia in 1928 by Griffith to find out the genetic nature, but it was done not for finding out the nature of the genetic material. Later only, the same experiment was repeated by different people to show that the transforming principle, converting what we have R strain into S strain, was nothing but the DNA. Griffith transformation experiment was repeated by 3 different people in 1944, but actually they did the experiment for nearly more than 10 years. Started the experiment from 1933 and concluded only in 1944. So anyway, we have to take the 1944. So in 1944 they did the experiment as per the book in noted 1. They reconducted or repeated the Griffith experiment in an in vitro system. In vitro system means outside the body. What for? To identify the transforming principle responsible for converting, that is, a virulent form or non-virulent form to a virulent form. That's why they did the experiment. Now they collected the heat-killed S cells extract. See, this is the extract that is having heat-killed S cells. That means it contains only the DNA, there is no outer coat, etc. Now, from this solution, the extract, now they removed the lipid sugar. So lipids and sugar, they were removed. And we have the proteins, RNA and DNA remain. Now, when this extract was added to a culture having R cells, what would happen? The R cells transform from its surface character, having smooth surface, and also became pathogenic. This is what generally when they were added, when the extract was added to the medium having R cells, the R cells become transformed into, that is, S cells, and also became pathogenic. Now, they wanted to find out whether it was protein or RNA and DNA genetic material. Now, they treat solution one by one with enzymes. The first one, protease. Now, they add protease enzyme to the culture having what is called actually, that is, S cells. So, they remove the protein. Now, the culture or the extract contains no protein. Now the second one, they add the enzyme RNase. So to remove the RNA, they have actually added, that is, RNase enzyme. Now the culture or the extract contains no RNA. The third case, they added DNase to digest the DNA, to remove the DNA. So the DNA has been completely removed from this extract. So protein is removed, RNA is removed, in another case DNA is removed. Now they add the extract to a culture having all living cells and observe for the transformation. Whether transformation is taking place or not by testing the presence of S cells. Now this is culture having all cells, culture having all cells, culture having all cells. Now they add the extract, the one without protein. When added here, transformation is taking place. Now the all cells get converted into S cells. So S cells appear. So from that we conclude that the protein is not the genetic material. Then in the second case, he added the extract to a culture medium having all cells and observed for the presence of S cells. Now here too the S cells appear. The meaning for that one, the RNA is not the genetic material. It never inhibits what is called the transformation process. So in the first two cases, the transformation was not inhibited. So we can say either protein or RNA were the genetic materials. Such cells having such cultures having S cells are called transformed cells. The third case, now the extract without DNA was added to the culture medium having the R cells. What would happen? No formation of S cells because the digestion of the DNA took place. When there is no DNA, normally no transformation because DNA absence inhibits the transformation process. So digestion with the DNA inhibits transformation, suggesting that the transformation was caused by DNA. If DNA is present, definitely we have actually what is happening, that is S cells appear. But here there is no S cells. So from that it was concluded that DNA is a genetic material and not RNA and protein. So the process or the phenomenon by which the DNA from one cell, for example S cell, is transferred to another cell, what is called R cell, so that this R cell can retain some of the properties of S cell. So it is given in a wrong way in your book. So the phenomenon by which DNA from one cell, that is R cell, when transferred to R cell, what is happening? It retains actually the properties of S cell. This phenomenon is called transformation process. But in the book it was given when DNA from one cell, say an example R cell, was transferred to S cell. Now the S cell, actually is that one they given, they retain some of the properties of R string. This is the way given in the book. What I am writing in red is a wrong one. Normally DNA, the definition for transformation process, the DNA from one cell type, what is called S cell, when transferred to R cell, now it enables the R string with some of the properties of S cell. This phenomenon is called what is known as transformation. So there is a physical transformation of one cell into another cell. That is, normally the R cell gets converted to S cell. This is because of the transfer of DNA from the S cell to the R cell. So the genetic material in the case of that is Streptococcus pneumoniae is nothing but the DNA and not the protein and not the RNA. Here in these two cases, no protein, no RNA. But you see that one, S cells appear, S cells appear. When the DNA is absent, there is no transformation. So the transformation was caused by DNA and not by RNA or protein. So this is the conclusion made by them. So they studied the genetic material DNA and concluded DNA as genetic material only in the bacterium. In the bacterium, that is Streptococcus pneumoniae, and not in all cases of actually cells. They form DNA as genetic material only in the bacterium, the one which causes pneumonia, not in the case of all other types of cells. So the nature of DNA as genetic material in all the living organisms was proposed by two different people, and they conducted the experiment and proved universally DNA is a genetic material. Let's see now the next one. Though Griffith's transformation experiment, Avery and et al. Experiment, proved that DNA is a genetic material, still some biologists believed that the protein is a genetic material. If you are taking the eukaryotic cells, it contains about equal or just naturally equal proportion of both DNA and the proteins. Even the proteins have sufficient chemical diversity and complexity that provided information needed for actually that is the formation of genetic material. That's why the protein is considered as a genetic material. But in 1952, the experiments proposed by Hershey and Chas proved that DNA is a genetic material. DNA is a genetic material. What they did? So they did experiments in the case of bacteriophage, a virus, a T2 virus, a bacteriophage, which infects the E. coli bacterium. Now, they allowed this T2 bacteriophage to infect the E. coli bacterium and found that what's happening? Actually, the cell lyses with the production of, that is, a phage. A number of phages produced. And this is because of some materials from the virus entered into the bacterial cell and produced the progeny. They wanted to know what was the material that entered into the bacteria from the virus. For that, they made a system. They are designing a system. You know that one, this T2 bacteriophage is infecting what is in the bacterial cell, which is normally here. They are taking non-radioactive labeled what is called the bacterial cell. Now this is a bacterial cell and this is a phage bacterium. Now they allow the bacterium just to be infected with what is called the virus, and then what would happen? Progeny form and the cell lyses. Something transferred from that is a virus into the bacterial cell for the formation of the phage virus. Now they want to know what is the material that was entered into the bacterial cell for the production of many progeny virus and also caused the lysis of the cell. Now they design a system. Suppose you are taking, for example, before that, if you are just analyzing the nature of the nucleic acid, the nucleic acid contains phosphate or phosphorus. And if you are taking the proteins, there are no phosphate or phosphorus in proteins. We have phosphate or phosphorus is found in nucleic acids but absent in protein. Again they analyze the cell. The cell contains protein, but the protein, actually you see in the case of capsid we have protein is present. In the case of this DNA we have that phosphorus is present. So that is one of the reasons why they have chosen the protein and DNA, whether protein and DNA that was transferred. Protein or DNA that was transferred. Now we have phosphorus in the nucleic acids DNA and protein in the capsid coat. So protein is, normally you can say this, actually protein mainly, you know that one, cysteine and methionine, they contain sulfur. So in the capsid coat protein, he form sulfur is present exceptionally in the case of cysteine and methionine amino acids. That sulfur is absent in the DNA. And similarly, phosphorus is present in DNA but absent in protein. That's why I have chosen just actually the capsid coat and analyzed biochemically. Now, he designed an experiment by using a radioactive phosphorus or phosphate P32 and a radioactive labeled sulfur, that is S35. So he designed an experiment by using radioactive labeled phosphorus P32 and radioactive labeled protein S35. And he just used this one, phosphorus and sulfur radioactive label, to keep the virus track for a protein and virus, for protein and then sulfur during the infection process. So he designed an experiment by using the radioactive phosphorus P32 and S35, the protein, and that is what is called S35, a protein with the sulfur. In the protein only we have the sulfur, not in the case of nucleic acid. And separate the track of virus for protein and DNA during the infection process. Now what he did again? Now he cultured. So he infected the bacterium in a culture medium. The medium contained either what we have, that's phosphorus 32 or sulfur 35, both are radioactive label. While the medium was actually having either P32 or S35. When the phage virus was cultured, it took, that is 32 in its DNA, that is radio label, and the capsid protein is S35. When the virus was allowed to infect the bacterium in a medium, the culture containing either P32 or S35. In one medium, the culture contains P32. In another medium, the culture medium contains S35. When the phage was cultured in a medium with P32, it was grown there. It was labeled with P32 in its DNA. Similarly, when the phage was cultured in a medium with S35, now the capsid coat with the protein was labeled with S35. That is the main purpose of labeling the protein, the capsid, outer capsid, and the DNA with P32 by culturing in two different media of P32 and S35. So now they obtained, that is a phage with P32 on one side, one track, and a phage with S35 in another track. Now what they are doing in the next step? The differential labeling useful or enabled, that is Hershey and Chas, to identify the DNA or protein of phage. Now they mixed first, that is a virus with a core protein with S35 to infect what is called the non-labeled bacterial cell, that is E. coli. So they mix a phage with the S35 protein, that is S35, that is protein in the capsid, was allowed to infect, that is the bacterial cell, which was non-radioactive label. Now, in order to remove the heads or in order to loosening the phage particles, now the bacterial cell was generally, that is blending in McDonald's blender. So that now what will happen? The phage heads are removed. You see that one phage heads are removed. Phage heads are removed because of the blending, agitating, that is what is called the bacterial cell in a blender. Used for that one is McDonald's blender. So now the capsid coat alone removed. And these are all called supernatant. Supernatant. The capsid coats without nucleic acid inside are called as the supernatants. Now this is allowed to infect what is called the bacterial cell. Then they form, after what is called the progeny being formed because of entry of something from the virus particle into the bacterial cell, the progeny being formed, and we are doing the blending process just before the lysis of the cell, not after that one. Before lysis, the the blending process is being done to loosen what we have the phage particles from the surface of the bacterial cell. Now, when the phage was tested for that is radioactivity, it contained no S35. S35, that is a supernatant present outside the bacterial cell formed in the surrounding medium. There only you see that when the phage hits are present, the one which was removed by blending process, they only contain S35, but the newly formed that is phage viruses did not contain any protein with S35. The meaning for that one, this capsid coat never entered into the bacterial cell to produce its copies. It is only the DNA, the nucleic acid from the virus entered into the cell. So we have, that is the DNA is not labeled in this experiment. So we have only the progeny, almost no that is radio-labeled S35 protein with non-labeled DNA present. And when it was tested for radioactivity, the bacterial cell was non-radioactive because of the absence of any radioactive substance inside the cell, because the protein with S35 left outside the bacterial cell and it was not transferred from the virus into the bacterial cell, and it was found only in the surrounding medium, not that is in the form of supernatant, and it was not there. So it was not there in the bacterial cell because it is only the DNA entered in the bacterium and not the capsid coat which was left outside. That's why we have no S35 protein inside the bacterial cell. And also we have non-radioactive labeled DNA. In one track of the experiment, Hershey and Chas now allowed the bacterial cell to be infected with a phage labeled with S35 protein. Now this is S35 protein found in the capsid. So now the DNA is not labeled. So during the process of what is called infection, the phages are produced, and in order to loosening the phages from the bacterial cell, they were allowed to be blended or agitated gently by using what's called McDonald's blender. So the phage heads are removed, and these phage heads are only the capsid coat or called the supernatants. Now the cells are infected, many phages were formed, the cell lysis. The agitation was done only before the lysis process. Now, when the phage were tested for radioactivity, they contain no S35 labeled protein because S35 labeled protein was present only in the capsid coat. The capsid coat was left outside the head. So there was no entry of protein into the bacterial cell. It is only the DNA, the one which was non-labeled, entered into the cell, causes the production of many progenies, and these progenies have now only non-radio labeled DNA and no complete absence of that is a protein with S35. So from this one-sided track experiment, they proved that only the DNA entered into the cell and not the protein. The protein was left outside in the surrounding medium. So we have the proteins only in the surrounding medium and not associated with the bacterial cell. So this is one. They also did actually another process of separate track. In that one, a phage with P32 labeled DNA phage infects non-labeled bacteria. You see that one? This is a non-labeled bacterial cell. It was infected with what is called a phage with the DNA label with the P32. So now the P32 entered here, leaving the capsid coat outside. So there was no entry of protein into the bacterial cell. It was only the DNA with P32 entered the cell. Now infecting the cell, the bacterial cell with the labeled DNA. Now the infected cell remained, and before it just lyses. Now it was agitated gently by using McDonald's blender to loosen what we call the capsid or the phage particles from that is infected bacteria. Now this phage is removed. See that when the DNA enters, now by means of blending, gentle agitation, now what we have, only the DNA entered and the non-labeled protein code remains outside. Now the infected DNA, the entered DNA caused the formation of many phages. So infected cell remain, progeny phages form, cell lysis occur. And also we have dimension about the agitation by using the blender could be done only before lysis of the cell. So when the progenies were tested for radioactivity, they contain some P32 radial labeled DNA. So progeny phages contain some radial labeled DNA and there was no protein entered inside. The capsid was left inside. So when radioactivity was done, so the bacterial cells show the phages with only that is P32 radial labeled DNA. So from this, it was from these two tracks of experiment. In one track, that is the phage with S35, the protein code was labeled. In another track, a phage with P32 phosphate or phosphorus was labeled DNA allowed to infect. So this is an experiment. As no protein code entered here, as only the DNA entered into the cell and caused the production of progeny with radial labeled DNA and not actually the progeny with radial labeled protein. It is left outside only. It is only the DNA alone enter the cell. That is why we have in the resultant phages we have P32 DNA. And in the first case we have the bacterial cells which are not radioactive. In the second case here, the left side what we have, the resultant bacterial cells with the phages are radioactive. This is because of the presence of radial labeled DNA with P32. That's why it is radioactive and that bacterial cell is non-radioactive. So from this we concluded that the DNA is the genetic material and not the protein or RNA, the genetic material. Here this is between the competition actually between protein and DNA, which is a genetic material, either the protein or DNA. But this experiment confirmed that DNA is a genetic material that has been entered from the phage into the bacterial cell and caused the production of phage particles with radial labeled DNA and not with radial labeled protein.